All right, good morning, guys. Let's go ahead and get started. So, if JKLM is a parallelogram, find its perimeter. To get started with this, we're just going to be going and using our properties of parallelograms, of kites, of trapezoids in order to solve each of these problems today. As we solve each problem, of course, keep track of which property we're using and make sure that you guys are drawing on the picture itself because that will help out quite a bit. So for this first one, the property that we'll use to find the perimeter of this parallelogram is that opposite sides of a parallelogram are congruent. So I know that JK will be congruent to ML, KL will be congruent to JM. So that allows me to set up two equations. 6x minus 14 is equal to x plus 11. And our other red equation up here, 3y minus 4 is equal to 5y minus 22. Two things are congruent, we can set them equal to each other. From here, we're just going to go ahead and solve for each variable, x and then y. So solving for x first, we subtract x from both sides, giving us 5x minus 14 equals 11. Adding 14 will give us 5x equals 25, and dividing both sides by 5 gives us x equals 5. From there, we go ahead and we move over to our red equation to solve for y. We start by subtracting 3y from both sides, giving us negative 4 equals 2y minus 22. Adding 22 will give us 18 equals 2y, and then dividing both sides by 2 gives us y equals 9. Now that we have both x and y, we can go ahead and plug in, and I don't need to plug into both sides, because again, opposite sides are congruent, so I only need to plug in for one. If I plug 5 in for x, we get 5 plus 11, so LM and JK are both 16. Plugging 9 in for y, I'd get 3 times 9, which is 27, minus 4, which is 23. So the red sides are 23, blue sides are 16. If that's the case, the perimeter is just adding up all those sides, so we can do 23 plus 23 plus 16 plus 16, which is a total of 78 units. So the distance all the way around this parallelogram is 78. All right, next up. If QRST is a square, find RT. So to begin, since this is a square, we know all four sides are congruent, and also all four angles are right angles. So if that's the case, this will create a right triangle for us, and if we have a right triangle, we can use Pythagorean's theorem. A squared plus b squared equals c squared. C will always be our hypotenuse, the side opposite the 90 degrees. A and b will be our legs. So I have 18 squared plus 18 squared equals RT squared. 18 squared is 324, so 324 times 2 is 648 equals RT squared. From here, we take the square root of both sides, and we get RT is about 25.5 units. To be more exact, it would be 18 radical 2 units. Either answer is correct. 18 rad 2 will be a little bit more exact because it won't be a rounded decimal. It'll be very exact. It'll be an irrational number. All right, next up. If ABCD is a rectangle, find the measure of angle ABD. So first off, if it's a rectangle, we know opposite sides are parallel because a rectangle is also a parallelogram. If opposite sides are parallel, that means that BD is a transversal line. So BD crosses through both of those parallel lines. If that's the case, the relationship between angle ADB and angle CBD is that they are on opposite sides of my transversal line. They're inside the parallel line, so they're alternate interior angles. And we know alternate interior angles are congruent. So because of that, we can set these two angles equal to each other. So x plus 18 equals 4x minus 15. Then we can solve for x. Subtracting an x from both sides will give me 18 equals 3x minus 15. Adding 15 to both sides will give me 33 equals 3x, and dividing both sides by 3 gives us x equals 11. Now that we have x, I can go ahead and plug back in to find out the blue angle that we have in both of these. So plugging back in, we get 11 plus 18, which is 29, so both blue angles are 29 degrees. Now further, we know that this is a rectangle, and rectangles have four right angles. So I know all of angle ABC, this angle right here, the whole thing, is equal to 90. I also know the blue angle is equal to 29, so I can find the measure of angle ABD, because angle ABD plus 29 degrees will equal 90 degrees total. So setting up our equation, angle ABD plus 29 equals 90. Subtracting 29 from each side, we get angle ABD is equal to 61 degrees. All right, next up. If VWXY is a kite, VY is equal to 37, XV is equal to 24, and WZ is equal to 10, find WY. So first off, draw everything up in this picture that you know of. So start by drawing everything up that we have. And then from here, we also know that this is a kite. So a kite has some very specific properties. One of those properties is that the diagonals, the lines that are going through our figure, are perpendicular to each other. So they all intersect at 90 degrees. Also, we know that one of these diagonals is being bisected. So looking at WY, of course, ZY seems much longer than WZ, so that diagonal is not being bisected. However, XZ and ZV look to be relatively the same size, so that is actually the diagonal that's being bisected. So again, kites have perpendicular diagonals, and also one diagonal is bisected, so if the whole thing of XV is 24, if it's being bisected, ZX and ZV are both 12 units total. From here, we can use Pythagorean's theorem, because we now have a right triangle. We have the hypotenuse, C. We have a leg, which can replace A or B. So I now have ZY squared plus 12 squared equals 37 squared. 12 squared is 144, 37 squared is 1,369. Subtracting 144 from both sides will give us ZY squared equals 1,225. To get rid of the square, we take the square root of both sides. Taking the square root of both sides, the square root of 1,225 is 35. So therefore, ZY is 35 units. Lastly, we're looking for WY. So I want to start at W, go all the way to Y. So I'm just going to go ahead and use segment addition. So WY is equal to WZ plus ZY, which is 10 plus 35. So WY is equal to 45 total units. Next up, if DEFG is a rhombus, find the measure of angle DGF, this full angle over here. So first off, since this is a rhombus, I'm given that we have these two angles. These are the only angles that have measures here. Now, if that's the case, I can use these to set up an equation, because in a rhombus, we know that diagonals are angle bisectors. So these two angles are congruent because they're being split in half by DF. So if they're congruent, I can set them equal to each other. 4x plus 1 equals 7x minus 23. From here, I'm going to go ahead and solve for x by subtracting 7x from both sides, giving me negative 3x plus 1 equals negative 23. I'll then subtract 1 from both sides, giving us negative 3x equals negative 24. Lastly, we divide both sides by negative 3, giving us x equals positive 8. Now that we know what x is, we can find out what these actual angles are by plugging 8 back in. 4 times 8 is 32, plus 1 is 33. So each of these blue angles is 33. That means that the full angle is 66. So since this is a rhombus, we know it's also a parallelogram, because it's within the parallelogram family. And if that's the case, that means that we have consecutive sides that are supplementary, consecutive angles that are supplementary. So angle D plus angle G is equal to 180 degrees. So we can set that up. Since both angles are 33, we can say 66, because 33 plus 33 will give me 66 plus the measure of angle DGF, this angle that we're trying to find, is equal to 180 degrees. Solving for angle DGF, we'd subtract 66 from both sides, giving us DGF is equal to 114 degrees. Next up, if PQRS is a parallelogram, find the measure of angle R. So first off, if we're going to go ahead and find the measure of angle R, we're given this parallelogram. Ignore the answer for right now. We're going to try and see if we can get to this answer, because this is the answer for the problem. So if we're looking at this, we're only given these two angles. And if that's the case, these are not opposite angles, so they're not going to be congruent, but they are consecutive angles. One comes right after the next. So therefore, these are supplementary. And in fact, since it's a parallelogram, we know that parallelograms have two sets of parallel sides, which means that these are same side interior angles, which we know are supplementary. So if that's the case, I can say angle P plus angle S equals 180 degrees. And I'll just go ahead and substitute values in for angle P, 2x plus 25, and angle S, 7x minus 61. That'll give me 2x plus 25 plus 7x minus 61 equals 180. And when we combine like terms, we get 9x minus 36 equals 180. From here, we'll add 36 to both sides, giving us 9x equals 216. And lastly, we divide both sides by 9, giving us x equals 24. So we now have x. Now, we're trying to find the measure of angle r. So what other property can we use within parallelograms to solve for angle r? Well, we know that angle P and angle R are congruent because opposite angles are congruent. So if that's the case, I plug 24 back in for x, and if I can solve for angle P, then I have angle R. So angle R is equal to 2 times 24 plus 25. 2 times 24 is 48, plus 25 is 73 degrees, our final answer. All right, next up. If LMNO is a trapezoid, find the measure of angle N. So first off, if we have a trapezoid, all we know is that bases are parallel. And we know that we can tell a base from a leg because if it looks like it's parallel, those are the bases. So MN and LO are parallel to each other. Now, if that's the case, NO is a transversal line, and angle N and angle O are same side interior angles. And we know same side interior angles are supplementary. So therefore, we can say 9x minus 32 plus 3x minus 16 equals 180 degrees. Combining like terms, we get 12x minus 48 equals 180 degrees. And when we add 48 to both sides, we get 12x equals 228. Lastly, we divide both sides by 12, and we get x equals 19. Now that we have x, we can go ahead and plug it back in for angle N, because that's what we're trying to solve for. So I plug 19 in for x for angle N, and we have angle N is equal to 9 times 19 minus 32. 9 times 19 is 171 minus 32, which will give us our final answer of angle N equaling 139 degrees. Next up, if ABCD is a rhombus, AC is equal to 18, and the perimeter around ABCD is 52. We want to find the length of BD. So to get started on this, first off, since this is a rhombus, we know all sides of the rhombus are congruent and that the diagonals are perpendicular bisectors. So if AC is 18, that means that AE and EC are both 9 units. And since the perimeter is 52, it's split between 4 congruent sides. I can do 52 divided by 4 congruent sides to get me 13 units per side. At this point, I now have a right triangle. So I can go ahead and use Pythagorean's theorem to solve for BE. And then I can double it, and that will give me BD. So let's go ahead and start by solving for BE. Using Pythagorean's theorem, we're going to use a squared plus b squared equals c squared. And at this point, 13 is my hypotenuse. It's the side opposite the right angle. 9 is a leg. BE is a leg. 9 squared will give me 81. 13 squared will give me 169. Subtracting 81 from both sides will give me BE squared equals 88. And then taking the square root of both sides will give me BE equals radical 88, or 2 radical 22. Now, that just means that BE is 2 radical 22. That's its length. And of course, you can change this to a decimal if you want. I encourage you guys to work on simplifying radicals if possible, but it's fine if you do leave it as decimal. Now, from here, if I have this length of 2 radical 22, I want to find out the full thing. I just need to double it. So 2 rad 22 times 2 will give us 4 radical 22. That is the total length of B to D. All right, next up. If WXYZ is an isosceles trapezoid, find the measure of angle W. So First off, an isosceles trapezoid. Within isosceles trapezoids, we know base angles are congruent. So angle X and angle Y are the same angle. So if that's the case, I can set them equal to each other. 9x plus 15 equals 14x minus 50. From here, we're going to go ahead and solve for x by subtracting 9x from both sides and adding 50 to both sides. It'll give me 5x equals 65, and then dividing both sides by 5, we get x equals 13. Now that we have x, we can go ahead and we can solve for either angle y or angle x. It doesn't matter. They're the same angle. So I'm going to go ahead and plug in I'm going to plug in x for angle y, and we'll get 14 times 13 minus 50 equals angle y. Now it'll give us angle y equals 132 degrees. So I know both these angles are 132 degrees. Now further, since this is a trapezoid, the bases are parallel, which means angle y and angle z are supplementary, angle x and angle w are supplementary. Well, since angle y and angle x are the same, that means that 132 degrees and angle w are supplementary. So angle w is equal to 180 minus angle y. That'll give me 180 minus 132 degrees, which is 48 degrees total. All right, next up. If CDEF is a kite, find the measure of angle CDE. So first off, if it's a kite, I know that the diagonals will intersect at 90 degrees. They're perpendicular to each other. So if that's the case, I can go ahead and focus in on triangles, because I now have right triangles, which opens up Pythagorean's theorem and also angle measures. So if that's the case, I know that if I add up all three angles of this triangle, it will equal 180 degrees, because it's a triangle. It's not a quadrilateral now. It's three sides. So I have 4x plus 3 plus 20x minus 9 plus 90 equals 180 degrees total. Combining like terms, we get 24x plus 84 equals 180. Subtracting 84 from both sides gives us 24 equals 96. 24x equals 96. Lastly, dividing both sides by 24, we get x equals 4. Now that we have x, we can go ahead and plug it in for angle CDG, and we'll find out part of the angle that we need. So 20 times 4 is 80. 80 minus 9 is 71. So CDF is 71 degrees total. Now, I'm going to go ahead and focus in on angle EDG. If I find EDG, then I can just combine these two angles and we'll have the full amount. So for angle EDG, I'm going to do the same thing. 90 plus 59 plus angle EDG equals 180 degrees. Now if I manipulate that a little bit, I can just do angle EDG is equal to 180 minus 90 minus 59. That will give me, when I subtract all of those, 31 degrees. So if I want angle CDE, that's our goal, and I just combine 71 and 31 to give me 102 degrees total. All right, next up. If DEFG is an isosceles trapezoid, HG is equal to 7, EH is equal to 9x plus 2, and EG is equal to 16x minus 5, find DF. So, in an isosceles trapezoid, it has a very unique property that the diagonals are congruent. It's the same property that we have within rectangles. And because of this, we can go ahead and know that EG and DF are the same. So if I can solve EG, then I have DF. Now, first thing that you want to do is you want to label everything in your picture. So I went ahead and did that myself. And looking at this picture now, I can see that I can use segment addition. So I can say EH plus HG is equal to EG. So 9x plus 2 plus 7 equals 16x minus 5. Combining like terms, we get 9x plus 9 equals 16x minus 5. And then I'm going to go ahead and subtract 9x from both sides and add 5 to both sides. That'll give me 14 equals 7x, and when I divide both sides by 7, we get x equals positive 2. Now, again, I only need to find EG, because EG and DF are the same, so I plug 2 back in for EG. We get 16 times 2 minus 5. That'll give me 32 minus 5, which is 27 units total. So DF is equal to 27. Next up, if GHIJ is a parallelogram, HK is equal to 36 minus 2x, and KJ is equal to 3x plus 11. Find HJ. So again, first thing that you should do is you should draw everything on your diagram and look for anything that's useful. So for this one, we have two diagonals that they give us, and we know diagonals in a parallelogram bisect each other. So therefore, they're cutting each other in half. So if that's the case, these two pieces should be congruent. And if they're congruent, that means that we can set them equal to each other. From there, I'm going to go ahead and add 2x to both sides and subtract 11 from both sides, giving me 25 equals 5x. From there, I divide both sides by 5, giving me x equals positive 5. And then I can go ahead and plug back in. So if I plug 5 back in for x, then I have 36 minus 2 times 5, or 36 minus 10. That will give me 26. So h to k is 26. If I double that, I'll have hj. So hj is equal to 2 times hk. If hk is 26, 2 times 26 is 52 units total. All right, next up. If ABCD is a trapezoid with mid-segment EF, find ABCD's perimeter. Now, we haven't covered this much at all. We saw the midline theorem, the mid-segment theorem with triangles. Now we're actually seeing the mid-segment theorem with trapezoids as well. So I'm going to give you guys an equation that we can use with this. So, with the mid-segment theorem in trapezoids, it's the same type of thing where E and F are both midpoints. They create that mid-segment. So therefore, we have this opposite side being 5, this opposite side being 9. Because again, if it's the midpoint, it's being split into two congruent parts. We also have the mid-segment theorem, which says the mid-segment is equal to the average of the top base and the bottom base. So if I add the bases together and divide by 2, that will equal the length of EF. So let's go ahead and do that. We have 2x minus 3, EF, is equal to AD, 23, plus BC, 3x minus 13, divided by 2. From here, I'm going to go ahead and get rid of this 2 on bottom first by multiplying both sides by 2, giving me 4x minus 6 equals 10 plus 3x. Again, I combine like terms here as well. From here, I can go ahead and solve for x by subtracting 3x from both sides and adding 6 to both sides, giving me x equals 16. Now that we have x, we can go ahead and plug back in, and we can find out this missing side length. So 3 times 16 minus 13 will give me 48 minus 13, which is equal to 35. Lastly, we just add up all our sides together, so our perimeter is equal to 5 plus 35 plus 9 plus 9 plus 23, for a total of 86 units. All right, next up. If EFGH is a kite and the measure of angle FGH, this angle here, is 94 degrees, find the measure of EFG. EFG is this top angle. So to get started, we have a kite here, and I know that this angle is 94, so I should probably draw it in. I also know that we have a pair of angle bisectors at one of the angles, and that one pair of opposite angles are congruent. So angle E and angle G are congruent to each other. Now, at this point, I know that within a kite, that the total sum of degrees that we have is 360. So we're going to go ahead and use that in just a bit. However, since this angle down below is being bisected, I can use that to my advantage right now. I can say 2x plus 7 is equal to 4x minus 23. From there, I can go ahead and solve for x by subtracting 2x from both sides and adding 23 to both sides, giving me 30 equals 2x. Then dividing both sides by 2, we get x equals 15. If I plug back in, I can find out what this missing angle is. So plugging 15 back in, 4 times 15 is 60. 60 minus 23 is 37. So I know both these purple angles are 37 degrees. We also learned that in any quadrilateral, any four-sided shape, we have 360 degrees total. That's one of the first things that we learned yesterday. So if I add up angle F, E, G, and H, it will equal 360 degrees. So I can do angle F plus angle E plus angle G plus angle H equals 360. The only angle that I don't know is angle F. Angle E and G are both 94. Angle H is 37 plus 37, or 74. So solving for angle F, we get angle F equals 98 degrees. All right, next up. If PQRS is an isosceles trapezoid, RSTV is a rhombus, RT is equal to 28, SV is equal to 34. Find QP. So first off, we're going to go ahead and draw in here and use some of our definitions of, some of our properties of rhombi, as well as isosceles trapezoids. So to begin, we know diagonals in a rhombus bisect each other and are perpendicular. So if RT is 28, then R to the intersection is 14, and the intersection to T is 14. S to the intersection is 17, and the intersection to V is 17 as well, because SV is 34. And since diagonals bisect each other in rhombi, those are congruent. From here, we know that they're perpendicular as well, which creates a right triangle for us. And if we have a right triangle, then we can use Pythagorean's theorem. So we have a squared plus b squared equals c squared, where a is 17 and b is 14. VT, our side length, will be our hypotenuse. 17 squared is 289, plus 14 squared is 196. Combining those two together, we get 485 equals VT squared. Take the square root of both sides, we get VT is equal to the square root of 485, and that is our length of VT. Now, since this is a rhombus, all sides are radical 485. So RS is also 485. And since we have an isosceles trapezoid, we know that the legs are congruent. So RS, VT, and QP all are length radical 485. All right. If CDEF is a rectangle, DHGE is a parallelogram, and the measure of angle BEG, this whole angle here, is 138 degrees. We want to find the measure of angle H. So, to get started on here, we're going to go ahead and draw. We didn't draw everything, but we did start with vertical angles being congruent. So these two angles that we do have are congruent to each other because they create this x, and we know vertical angles are always congruent. So 7x minus 24 equals 4x plus 6. If I subtract 4x from both sides and add 24 to both sides, we get 3x equals 30. So therefore, x is equal to positive 10. From there, we can go ahead and we can solve to find out this angle up top here, angle DBE. So I plug 10 back in, and I get 7 times 10, which is 70, minus 24, which is 46. So I know both these red angles are 46, and this top angle will be 134. I know this top angle is 134 because we have a linear pair, a pair of angles that are supplementary. And so these two angles will add to be 180 degrees. From here, we also know angle BEG is 138 degrees from what we learned earlier. And because this is a rectangle, this is actually an isosceles triangle here. So we have an isosceles triangle, which means that base angles are congruent. So therefore, we can go ahead and set up an equation. I'm going to go ahead and call both those base angles z. So I'm going to have z plus 134 equals 180 degrees. Combining like terms gives me 2z equals 46. When I divide both sides by 2, we'll get z is equal to 23 degrees. So both purple angles are 23. From here, I'm going to go ahead and find angle E, because I know opposite angles are congruent. So if I find angle E, then I have angle H. So for angle E, I can do 138 degrees minus 23 degrees, which will give me 115 degrees total. So angle E is equal to 115 degrees, and since opposite angles are congruent, angle H is equal to 115 degrees. All right. Lastly, if VTXW is a rhombus and WXYZ is a square, find the measure of angle VWZ. So, first off, if we have a rhombus and a square, I know all of these sides are going to be equal to each other because, again, they're all congruent. Further, in the rhombus, I know that the diagonals are going to be perpendicular. They're going to intersect at 90 degrees. So therefore, I can draw those 90-degree angles already, which allows me to set up an equation to find the missing angles. So I can say 2x plus 1 plus 5x minus 16 is equal to, plus 90 equals 180 degrees. Now I set those two angles equal to 90 degrees because if I did the whole thing, I'd subtract 90 degrees right off the bat, and then all of a sudden I'm already here. So from here I can combine like terms. 2x plus 5x is equal to 7x. 1 minus 16 is negative 15, so I have 7x equals negative 15. 7x minus 15 equals 90. Adding 15 to both sides, we get 7x equals 105. And then dividing both sides by 7, we get x equals 15. Now that we have x, we can go ahead and solve for these missing angles here. So for this top angle, 2 times x plus 1, that will give me 30 plus 1, which is 31 degrees, which means the full angle would be 31 and 31, or 62 degrees total. So angle STV is 31 degrees, and then if I'm going to double it, it'll be 62 degrees. We're trying to find angle VWZ. I already know that all 4 angles of a square are 90 degrees, and I also know opposite angles in a parallelogram are congruent. So therefore, angle VWX is 62 degrees. Angle XWZ is 90. 62 plus 90 will give me angle VWZ. So that will give us our final answer of 152 degrees. All right, lastly, here are all the properties of quadrilaterals. If you guys would like to pause this video and make sure that you have all of these down, it will be beneficial to you guys. Other than that, thank you guys so much for watching. If you need anything else,